So the next functional group we're going to talk about are amines. And so drawn below are three common amines, and we're just going to go through a very quick common way of naming these guys so that they're so common you'll just see them referred to as these names versus like rigorous names. So the first amine is called methylamine. The second amine is called triethylamine. So what this is saying is 1, 2, 3. There, 3 is tri, and each one of these are an ethyl group. So this is triethylamine. And then this molecule is diethyl. So instead of 3, we have 2. So 1, 2 is di, and each one of them are ethyl, so diethyl. So just like with the alcohols, if you see a nitrogen on a molecule, that's going to indicate to you that the overall functional group is going to be an amine, and so we have to try to name them with these rules that we're about to talk about. So just like if this was an OH, you would refer to it as an alcohol. If you see the NH2, this has to be an amine. And so what we're going to do is we're going to slightly tweak the parent hydrocarbon name. So for this molecule, we have 1, 2, 3, 4 carbons on the parent. So this would be meth, eth, prop, bute. So normally we would call this a butane functional group, so butane. But instead what we're going to do is we're going to get rid of that E, and we're going to replace it with amine. So now what we have is not a butane parent, but a butanamine parent. And so just like with the alcohols where we had to indicate where the OH actually was located on the parent, we have to do the same thing with the amines. So in this case, it's a very simple scenario that nitrogen is going to be attached to the first position. So all we have to do is add a 1 and a dash. So this 1, again, indicates the nitrogen is on the first 1 position, so 1 butanamine. So let's do a slightly more difficult example. So in this case, the parent is going to still have to try to include that nitrogen, just like we had to include the OH, but we could still number from either side, either from the left or the right. So if we number from the left, 1, 2, 3, versus numbering from the right, 1, 2, 3, 4. So we definitely want to number from the left, 1, 2, and 3, trying to, again, minimize that numbering scheme. So in this case, we're going to say that the nitrogen is on the 3 position, and the overall parent is going to be 4, 5, 6. It's going to be a hex. But instead of hexane, we're going to change that to a hexanamine. And all we're going to do now is we just have to indicate where that nitrogen is, and that nitrogen's on the 3 or 3rd position. So 3-hexanamine. Okay, so now let's do a slightly more difficult example. What do we do if that nitrogen doesn't just have 2 hydrogens attached? Well, what if we actually have some more carbons attached to that nitrogen? We still want to utilize this longest parent right here, 1, 2, 3, 4, 5, and 6. So this is still going to be a hexanamine, and we're still going to have a nitrogen on the 3 position, so this name is actually going to be exactly the same at this point. So we can just copy paste. The only thing that we have to do is include this methyl group, right, or this ethyl group, excuse me, right here. And the way that we include the ethyl group is since it's not part of the parent, what we have to do is indicate that it's attached to the nitrogen. And the way that we do that is we have to include this N designation. So this is going to be an ethyl group, and it's going to be positioned or attached to the nitrogen. So we indicate to the reader that this is an ethyl group and is attached to the nitrogen with this N designation. And so now let's do one more, slightly more difficult example. And so in this case, we have 3 substituents on the nitrogen versus having, 1 substituent here. And what we have to do is figure out which of these 3 is going to be the parent. And again, the parent is going to be the carbon chain with the longest unbroken number of carbons. So right here we just have 1 versus 2 versus 3. And so that means that the longest unbroken chain is going to be here, 1, 2, and 3. So what we're going to do is when we are naming the parent for this molecule, we first have to recognize that it's an amine, and we're going to call this meth, eth, prop. We're going to call it a propanamine. And what we can do is we have to say what position the nitrogen is attached to. And so the nitrogen in this case is attached to position 1. And so then the nitrogen now has 2 substituents that we have to designate. And so just like before, the way we're going to do this is with this N designation. So this is going to be an N-methyl. And this is going to be an N-ethyl. And so then the last question is, how do we want to order them? And again, we're going back to, if we have multiple substituents, you want to try to order them in alphabetical order. And so in this case, ethyl versus methyl, ethyl is going to come first. And then after the ethyl, we're going to have our methyl. So overall, the name of this molecule would be N-ethyl N-methyl 1-propanamine.